We're going to get started. We're going to get started on today's lesson in just a little bit. The question over here that we've been given, it says we've been given the two graphs of m of x is equal to k over x plus q, and the hyperbola p of x is equal to mx plus c. We should be able to notice what kind of graphs are those because we just did them on Monday. Okay, we know that this is a hyperbola, and this is a straight line graph. And they've given us two straight line graphs on the screen. They've given us the point -3 and 0 over here, and they've given us the point 0, 3 over here, and they tell us that the asymptote of y, or the asymptote for m of x is at y is equal to 1. So this asymptote over here is at y is equal to 1, and they're saying to everybody, determine the equations of m of x and p of x. I'm going to give everybody a couple of seconds. Remember what the asymptote y is equal to 1 means for what we're doing here, and see if you can find me the answer for those. Hello, I'm sorry, I feel like it's me anymore. Anutida, what are you doing? What did you do to yourself? You need to check your settings, dude. Okay, pop your favorite emoji in the chat. Once you're done, remember, guys, you know, I mean, we love you all the same, Anutida, but I mean, you're a problem. What can we say? You're our problem. That's the nice thing. It's because I had to like stop share and reshare my screen. Hi, Leah. Okay, Leah's done, which is great. Hi, Leah. It's so great to have you with us again today. Our emoji, a smile. Hi. No. I'm kidding. I'm just kidding, Anushiya. You're very welcome here, and we're always here to help. I'll just stop sharing and reshare my screen. Don't stress. Okay. All right, guys, I'm going to give you 1 more minute and then we're going to get started on today's lesson. Muklu's done as well. A few more seconds. All right, we're going to get started. Okay, for those of you who have not yet figured out how to do these questions, that's easy. All right, we're going to start with m of x. Okay, let's start with m of x over here. And we know that when they've given us this information, m of x is equal to k over x plus q. We know that when they tell us that y is equal to 1, what is this value actually? What are we going to do with this 1 that they've given us over here? Which value is it in m of x? Hello, Isayan. Which part of my equation am I replacing it with? That's it, Nkechi, very well done. We're replacing it with q. So our q is going to be +1. So we're already off to a great start. We have m of x is equal to k over x plus 1, because that asymptote tells us that the whole graph, both graphs have been shifted up 1, so +1. Okay, great. And now in order for us to find k, I'm going to replace this m of x quickly with just y. What do I need to do in order to find k, guys? What's the information they've given me? What else have they given me? Anybody remember? Oh no, has everybody forgotten how to do this? Okay, if I want to find a, okay, I feel like, thank you, Nkechi. I feel like Nkechi is the only one who's like, yes, ma'am, we remember. Yes, we're gonna sub in a value. All right, we're gonna sub in a value that's already on the hyperbola. And the point that they've given us that's on the hyperbola is this one, -3 and 0. -3, and 0. So this is my x value, and this is my y value. So I'm going to replace those two with my x and my y value, and then I'm going to solve for k. So my y value is 0, so I'm going to write 0 is equal to k over -3 plus 1. And then I'm going to solve for k, guys. Give me a value for k. Therefore, I'm just going to go, therefore, k is equal to, what is k equal to, guys? What have we found? Quickly calculate for k and tell me what we get. Not 2. Okay, yeah, I don't think we'd get 2. We won't, Nkechi. Check again, double check again. Anybody else got an answer for me? Okay, remember the first thing we're going to do is we're going to take 1 over to the other side, and it's going to become -1. So we're going to have -1 is equal to k over -3. How do I get rid of that -3 in the denominator? I'm going to multiply. I'm going to cross multiply by -3. So I'm going to get -3 times -1, which is going to give me 3. Well done, Offense. That's it. Therefore, k is equal to 3. I can write it over here. K is equal to 3. All right. So all we're going to do is we're just going to cross multiply. Okay, guys. So the value for k we're looking for is 3. So the equation for m of x will be m of x is equal to 3 over x plus 1. Okay, and that's correct because our graph is sitting in the first and the third quadrant. Yes, Nkechi. Hello, Mamello. Hi, Nkechi.
Hi, ma'am. But it's fine. I got my answer. Sorry.
Okay, did you see the issue or the mistake that we made?
Thank you.
Okay. All right, my sweetie, you're welcome. You're very welcome. Okay, excellent. So the other one, P of X is our straight line graph, right? P of X is equal to mx plus c. What is my c value? Before we even continue, guys, what is my c value going to be? Look at your straight line. What is my c value going to be? Let's have a look at it. What is my c value going to be? Anybody? Think about it. Where do we find c? Good, Warona, that's it. In case you remember, it's always the y-intercept. So where the graph cuts the y-axis, my y value, which is 3. So we can already substitute into c over here, that c is equal to plus 3. The Slay Queen is back, everybody. She's been gone forever. Hello, Queen Kama. Love to see you. Awesome, awesome, awesome. All right, guys. We'll chat in just a little bit. Find me m, guys. M is the gradient. We do have 2 points. They've given us 2 points. They've given us the point over here and the point over here. No worries. I see somebody say, sorry, I'm late. Hi, Princess. It's awesome, awesome, awesome to have you with us. I love Tinswalo's response, Your Majesty. Love to see it. All right, guys, calculate my gradient for me. Tell me what the answer you get in the chat is. M is equal to something. Thank you, Offense. Michael's like, Your Highness. Excellent, Princess. Well done. Well done. So m is equal to 1. Remember, guys, when we calculate for m, that's the gradient. We use y2 minus y1 over x2 minus x1. Okay. Hello, Gabriel. Gabriel's back. I feel like this is the day of comebacks. Hi, Gabriel. Oh my goodness, everybody's coming back all at once. Hi, everybody. Sheesh, it's been a while, everyone. Where have you guys been? Chifaro as well, but I feel like Chifaro only came back on Monday. Welcome back, everyone. It's so great to see you guys. I saw you on Monday, Chifaro. So, oh, okay, but I get it. Of course you're back, because last time we saw you was only on Monday. Okay. Hi, Kachelelo. It's great to see you. So our two graphs that we're looking at, guys, are m of x is equal to 3 over x plus 1 and p of x is equal to 1x plus 3. Or you can just write x plus 3 because the gradient of 1 is just the same as x. We don't have to write the 1 there. I like to write the 1 there so that they don't forget that I got the answer right. They must give me my mark. Okay. All right. Well done, guys. Remember, the thing you're always going to do in a question like this where you have to find A or K is always use the asymptote. That's the first step. And then the second step is always to sub in a point. They will always give you a point to sub in. Okay. You just need to find the point. All right. Okay, and then in this one is easy. You always need to find the gradient m, and our c value is always the y-intercept. Okay, this is something we spoke about on Monday, and if you weren't here on Monday, you guys need to go have a look at that video over there. Let's take a deep breath in, everyone. We're going to get started on today's lesson. Okay. I know, didn't swallow. I know. All right, which is okay. All right, today we're going to be doing a bit of trig and Euclid revision. I've also thrown in a bit of analytical geometry as well. The reason why I want us to focus on these sections is because they make up the bulk of paper 2. Okay, and they're the ones that usually the people don't get the marks where they need the marks in the paper 2. The other sections that are still coming in terms 3 and 4 will also be included in this paper 2 roundup, but at the moment, there is no paper 2, there's no more to paper 2 other than what we've learned here. Okay, but by the time we get to the end of the lesson, not the end of the lesson, the end of the year, we will have covered everything that needs to be covered for your exams, and then we'll have a full picture of what you need to know for paper 1 and for paper 2. All right, without further ado, let's start with the question over here. It says, we are given the following right-angled triangle. And remind me again, guys, as soon as we see right-angled triangles, what do we need to think of? Give me all the things that we can possibly think of in the chat. Where should your mind go as soon as we see right-angled triangle? Excellent. I hypotenuse. Don't put your hand down. Don't put your hand down. Hypotenuse. What else? What else can we think of?
Hi, ma'am. Actually, hi.
Hello.
How are you, ma'am?
I'm good, thank you. How are you?
I'm good, ma'am.
Mm.
Right angle triangle. The first.
Oh no, I think she's frozen. Oh my goodness. Good. Okay. I'm gonna say Pythag. I think Utuking is like frozen a little bit. And I can't see. I saw somebody else say Sokatoa, which is actually what we're looking for. Hi, Utuking.
Hi, ma'am.
I lost you there for a second. What were you gonna tell us?
Ma'am, when I see a right angle triangle, I first think of the trigonometry.
Beautiful.
The trig ratios, and there are reciprocals, and so on.
Absolutely. The cousins. We need to think of the cousins. Sec and cot. Good. This is excellent. That's exactly what I wanted to hear. Sure. See, your mind must automatically go there. You see, this is how I already know you're going to get 100% for this section, because you already know where your mind needs to go. Love to see it. Good stuff. Well done. Takane, we could think of fun, but remember, we only think of fun angles when we have parallel lines. Okay. I agree, Michael. It does sound just a little Japanese. Hi, Kama.
Hi.
Hello. How are we doing? It's like you went on holiday and you just forgot about us. How?
No, ma'am, it's not even that. I was just super busy. I was like really busy.
Okay. I'm gonna believe you. I'm gonna give you the benefit of the doubt. How
No,
are we doing?
I promise. I promise. Like I was super busy.
Yeah. See, it was like somebody's come back from a real brain break. See, I think they're talking about
Ma'am, I was just going to ask, in the lesson, would we be able to cover like how to find the angle within the triangle?
Yes, yes, we're going to
Oh.
get, because you can see here, we've got a theta and we've got an alpha, and we're going to cover that just now. Okay.
Sure.
Okay.
Thank you so
Excellent.
much.
To you, voice girl, I haven't spoken to you in a while. Wow. It's
Oh,
been.
ma'am, the arts festival was hectic. Oh, God.
Oh, I see. She went to an arts festival, guys. Listen to this.
Oh, it was so hectic.
Arts festival, hey? Yeah, that's what we're calling holidays these days. We see you.
Thank you so much, ma'am.
All right. Oh, loving to see it. But Mamelo, what's up, my sweetie? All right, guys, let's answer the following questions. We need to find the
Hey,
value.
ma'am.
Hello, my sweetie, and the value of B. Go for it, guys. Pop your favorite
So-
emoji. Yes, Mamelo.
Instead of Sokatoa, at school I was taught to use another hour of algebra.
Oh. Oh, yes, I see it, because the SCT, like, did they say oh hell or oh heck? I don't know which one is a swear. Which one is
Another hour of algebra.
how? Your teacher's swearing. You tell your teacher that we need to wash our mouth out with soap. We don't swear.
No, ma'am. She wanted to make it easier for us to understand. So Sokato, I don't get it exactly like.
Oh, okay. Okay, if that one works for you, if the swear words are working for you, then you can use it. I love that one. I love that one though. Excellent. Mamela, I think I prefer, I'm gonna say Sokatoa, but you can think of that one. It's just my brain is programmed Sokatoa. So whichever one works for you, then we'll do that one. Mental abuse to humans, guys. Okay, let's talk about X quickly. Oh my word. Teacher Nelly, are you also there? Are you also there with them on this? I see you. All right, guys. So let's think about this. They want X. They want X. So what is X exactly? Is it an angle or is it a side? What are we looking for? What are we looking for? A side or an angle? Good. We're looking for a side, guys. We're looking for a side. Now, if we have to look for a side, is it going to help us to use Sokatoa? Now, remember, guys, Sokatoa uses angles. And we would need angles in order to use Sokatoa. Do we have any angles? Yes or no? Good, there is no angles. Okay, Albert, we can't use the angles. We can't use the adjacent side or the opposite side, but we do know that this is a right angle triangle. So what are we going to use to figure out what X is? That's it, Amy. Beautiful, that's it, Amkhalang. We're going to use Pythag. Okay, I'm going to give you guys a second. Give me the answer in the chat. Just type in the chat, X is equal to when you're ready. Okay, and then we'll talk about B. You've got exactly 1 minute, everyone. Pythag is not difficult. And then we'll talk about B. And if you're already done, have a look at B. No. Chifaro, I doubt that. Today's quiz is quite easy. I made it quite nice. I didn't make it difficult at all. It's very easy. Okay. Anutita says X is equal to the square root of 12. Don't look at it until the end of the lesson, Chifaro. Okay, Anutita says the root of 12. I want to see if everybody else agrees with him. Junior says root 20. I wonder who's correct between the two of you. Let's go have a look, everyone else. Okay. Root 20, 6.33. Okay, in this case, don't round off just yet. Okay, leave your answer underneath the surd. Okay, we want it to be as accurate as possible. It's fine, we do that. The only time we ever do that is if they've given that to us. Okay, Leah, check your answer again. Check your answer again. Okay, Udukreng says also root 12. Albert also says root 12. Anachita, it doesn't look like you've made a mistake. Everybody else is saying that. Okay, Amkhulang says, I've got none of those. Stephen is also giving me a decimal. Have a look again. Bongani, yours, yes. Bongani is one I'm seeing. Okay, I don't know about root 20. I don't know about root 12 either. Square root of 12. All right, let's have a look at this question very quickly. I believe 2 root 10. 2 root 10 looks about correct. Okay, so remember here, guys, x is a short side. If we were calculating for the long side, we would say short side squared plus short side squared equals long side squared, right? So now that we're not actually looking for the long side, we're looking for a short side, we need to take long side squared minus short side squared, minus short side squared. And that's how we're going to get the answer we're looking for. We're subtracting. Good. So we can say 7 squared minus 3 squared, and that's going to equal to x squared. Okay, so I know that x squared is going to equal to 7 squared is 49 minus 3 squared, which is 9. That's going to give me 40. So now I've got x squared is equal to 40. And now I have to take the square root of that to get rid of that square. So take the square root, take the square root. And I believe the answer I should get is x is equal to the square root of 40. Or if you've written 2 root 10, that is correct. That means you've used your calculator the right way by taking out that 4 that would make up the square root of 4, which is 2. All right, so your answer will either be x is equal to the square root of 40, or it will say square root 10. Okay, it wasn't 12. I see how we may have gotten confused, guys, but remember, we always need to look at which side it is that we're calculating. So now we know that x is equal to the square root of 40. Yep, we subtract, Leah, we do. All right, let's have a look at B quickly. B over here says, we want the sine of theta. Now, remember, those of you who do SOHCAHTOA, those of you who say, oh heck, algebra is terrible. No, I can get this. Oh heck, another hour of algebra. There we go, there we go. I got it. Okay. We add when we are looking for the longest side. So let's say, for instance, I've got a triangle and they give me that this side is 4 and this side is 3. Then if I'm looking for the hypotenuse, the longest side, I need to take short squared plus short squared will give me long squared. Okay. Okay. So, but this time, because we're looking for a short side, we say long side minus short side. Okay, so don't get confused, guys. We always need to look for that. Thank you, Nkubi. Nkuri also gave me a good answer. I see Leah giving me an answer as well. Okay, Nkuri, you need to pick one answer. You can't give me both. Okay, so let's have a look at what we need to do over here as well, guys. Okay, we know that x is equal to the square root of 20. All right, we want theta. We want sine of theta. So if I'm looking at theta, guys, theta is going to be 2 theta. My x side is going to be my adjacent. My opposite side, or my 3 over here, is going to be my opposite. And my hypotenuse is always the one opposite the 90-degree angle. So this is hypotenuse. Okay, and then we can use SOHCAHTOA. So sine of theta, what is sine? Or sine is opposite over adjacent. So sine of theta is equal to opposite over adjacent. How much is my opposite side? Oh, sorry. Oh, opposite over hypotenuse. Sorry, Kimotlutu. I keep saying adjacent. I don't know why. Opposite over hypotenuse. My opposite side is 3. And my hypotenuse is 7. So the answer is going to be 3 over 7. Sorry, Kimotlutu. Sorry, I caught myself. See. All right. Let's have a look, guys. Find me tan of alpha. The next question says tan of alpha. Now, remember, alpha is over here. Alpha is over here. So the sides are going to switch. This is no longer going to be the opposite side. This one is going to be the one next door. Now this is going to be the adjacent. Right. And then this side is going to be the opposite. And my hypotenuse will always stay where it is. So remember, tan of alpha is opposite over adjacent. Now, that's where I got the adjacent from. That's where the opposite over the adjacent was going. All right, so give me an answer for tan of alpha, guys. I'm not going to accept the answer x over 3 because we just went through a whole thing where we found out what x was actually equal to. So put in the correct answer for that. Thank you, Leah. That's the one. Okay, don't use x anymore. We need to use the answer that we found for x. Well done, Anutida. See, this time you got it. Yes, well done. Good. So we know that tan is opposite over adjacent. And then it says here, opposite is going to be root 40 over 3. Or you can also say that that is equal to 2 root 10 over 3. Okay, we can do either of those. Okay, now I need you guys to go grab your calculators, right? Because it says calculate for theta if alpha is equal to 64.62 degrees. Let's go back to our triangle very quickly. It says here, calculate for the, if alpha is 64.62 degrees, what is theta? Do we need to use any SOHCAHTOA to figure out what theta is? Yes or no? Yamukoko says yes, Anutida says no, Leah says no. I'm gonna go with the no's. But the no people need to explain to us why we will not use SOHCAHTOA. Why do we not need to use SOHCAHTOA to find theta? That's it. Angles, we're not solving for sides, Leah. We are working with angles, but we're not going to click shift. That's it. Aseza, mwah, beautiful. Guys, it's a triangle. It's a triangle. It's the sum of the angles in a triangle. So this question shouldn't actually be that difficult at all. Okay, it's the interior angle of a triangle. And Isabel has already found the answer for us. Isabel, you're a whole G. Love, love, love to see it. Now we already know that theta plus 64.62 plus 90 degrees, because there's a 90-degree angle. All of that needs to equal 180 degrees. And the reason for that is because of the angle sum in triangle. Okay, the sum of the angles in a triangle. Yes, that's it. And then we can just find that theta is equal to, thank you, Isabel. I also don't have my calculator. Thank you, 25.38 degrees. Okay, give me a thumbs up if everything we've just done, all the questions here, A, B, C, D, is everything okay? If not, then either give me a thumbs down or be like, ma'am, excellent, Bongani, I see your thumbs up, thank you. Okay, this stuff should be super easy by now. In fact, at the school where I'm at, we teach our kids this stuff in grade 9. That this is how easy it is, because by the time you guys get to grade 10, your brains are just like, they're basically transformers, and they should be able to get this quite easily. Okay, amazing stuff, guys. Awesome, awesome, awesome. All right, I'm gonna give you guys a chance to practice. Okay, Anutida, I'll tell you later. Okay, I'll tell you later. Okay, Princess, I'm gonna go up 5 seconds. 5, 4, 3, 2, 1. Okay, I'm done. Excellent, excellent. All right, here's a bit of practice for you guys. I'm going to give you about 5 minutes. Okay, now I want you guys to see here that they're saying here, determine without the use of a calculator. What does that tell me, guys? What are we using? If they tell us without a calculator, what should we be thinking? Anybody? If they give us things like cos and tan and all of these things, yes, Vaughn. And I realize you tricked us because we welcomed you as a new student, and Vaughn is the Vaughn that we know good. We're thinking of special angles. Good. Special angles, no calculator. So the first thing that we should remember, guys, as soon as we go into this, is we should remember our special angle triangles. Remember, I usually do this very quickly in my brain. I draw a 60 degree here, a 90 degree here, and then I go 1, 2, root 3 immediately. Okay, and then I draw my 45-degree angle, 45, and I go 1, 1, root 2, and I'm done. That's it. Okay, so it's very important, guys, that we remember to get our special angles in our head. Now, I do realize that you guys are in grade 10, and even though they say without the use of a calculator, if you are struggling, what are you going to use? If you're struggling with the stuff and they say without the use of a calculator, you're going to use your calculator. Use your calculator. Princess, good, you can use your calculator. Princess is like, my fingers and toes, ma'am. I've got 20. As long as they don't count more than 20, I'll be fine. Okay, good. I know, that one killed Princess, you took me. I love it. You're gonna use your calculator. But guys, remember, the more you know your special angles, the easier it becomes for the maths to move fast in your brain. Okay, so it's going to be easy for us to be able to do that. Okay. And Atita's like, that's what math stands for. Don't use a calculator. Yes, it stands for that. It does. Okay, excellent. All right, guys. So we're going to go for cos A. We're going to look for cos of A plus cos of B. But we know that A is 30 degrees. And cos of B is 60 degrees. Now, I saw somebody do this. I saw somebody in the chat go, cos of 30 plus cos of 60 is equal to cos of 90. Absolutely not. Absolutely not. You must use your special angles, guys. You must. Okay, remember, if this angle over here is 60 degrees, this one over here will be 30 degrees. So you can actually use this one triangle to solve for this. Anatita, that is not correct. You can only do that, Anatita, if we do this. If we go cos of 30 plus 60. Okay, then you can say that this is equal to cos of 90. All right, only then can you do that, which is consequently actually equal to 0. But in this case, no. We have to evaluate cos of 30 on its own and cos of 60 on its own. And if you are giving me decimals, then automatically they're going to say, look at this person using their calculator, because there's no way your brain would use a calculator and get decimals from these numbers and get the correct decimals. So when you punch it into your calculator, make sure you're not putting it in decimal form, guys. Otherwise, they're going to be like, oh, wrong. Try again, better luck next time. If you were a Sheldon, you'd already be in university, because Sheldon started university at 14. So you wouldn't be here. Okay. All right, so let's look at this, guys. They want cos of 30. We know that cos of any angle is going to be adjacent over hypotenuse. So if we go to our 30 degrees, adjacent to our 30 degrees is root 3, adjacent, opposite is 1, and hypotenuse is 2. So cos of 30 will actually be root 3 over 2 plus cos of 60. So now we have to switch it up, guys. We need to switch around. Okay, there we go. Now I have to switch. I have to say this is 60. This side is adjacent, and this side is the hypotenuse. So cos of 60 will be 1 over 2. Okay, and that's the answer they're actually looking for. We can put this together, and we're going to get the square root of 3 plus 1 all over 2. That's the answer they want. If you say all of this is equal to 0.86, they're going to be like, look at this one. They picked up their calculator and did the exact thing we didn't tell them to do. Okay. Yes, Nkechi. Nkechi, are you there?
Hi, ma'am.
Hi.
Ma'am, I wanted to ask, you see where the 60 and the 30 are, ma'am, how would you know where to put which one?
Because they've told us. They said that A is 30 and B is 60. So wherever I see an A, I'm going to replace it with
But like, huh? Wait, but it doesn't show where A and B are supposed to be. Like,
What do
how
you
would you
mean?
know?
Okay, so
Like, you see
if
where
I
you put
said to
60,
you-
it could have been
if I
at where
said to
30
you-
is.
Okay. Oh, you mean on the triangles?
Yes.
Oh, this I wrote it down from memory.
Oh,
I
okay.
wrote it down from memory. That's what I'm saying. For special angles, you need to memorize these triangles. Okay, you need to memorize the triangle. Okay, that's why the first thing I did when I said special angles, I did this 60 degrees, 1, 2, √3, because my brain does that for me. I've memorized it. Okay.
Okay, thank you.
All right, my sweetie. Okay, it's a memory game, guys. Like I said, you can punch it into your calculator, no worries. Your calculator will still give you the correct answer. But once you've committed all of these special angles to memory, your math starts moving faster and you stop wasting time clicking, and then now you need to click that other button with the thing over the thing plus the other thing, and then cos of the one thing, and then close bracket, click equals. It takes away the stress of having to do that because your brain is working faster. Okay. Oh, listen, you forgot the 90-degree angle. It's fine because I know my 90-degree angles. I know them because I know my mother graphs. Okay, because I know my mother graphs. So I can already tell you that the sine of 90 is 1 and the cos of 90 is 0. And I know that the sine of 270 is -1 and the cos of 180 is -1. See, mem is a whole G, man. And cos of 0 is 1. I got these, they're up here, guys. Here, I cook. In here, guys, I cook. Okay. You guys get it. Okay, Ande says, is B a third? Let's have a look. Let's have a look. Okay, so remember, guys, okay, let's have a look at this next question, guys. When they show us that there's a squared over here, right? What that tells us is, first we have to go and find tan of A. Tan of A is going to equal to something. And then after we found the tan of A, we need to square it. That's what that squared over there actually means. Okay, so I want you guys to use the special angles. Remember, A is 30 degrees. So we're going to replace A with 30 degrees. So please find me tan of 30 degrees, square it, and then give me the answer I'm looking for. Okay, something squared. Okay, Ratsepile says that the answer is 1/3, and I agree with you. I agree with Kahalelo and Relebogile as well. I just want to make sure everybody else is getting where they're getting this. Komukluklu is also correct. Okay, so we can go back to this triangle over here. We know that this is 30 degrees over there. Chifaro forgot to square. That's okay. We know that tan of 30 or tan is opposite over adjacent, because that's opposite to my 30-degree angle, adjacent to my 30-degree angle. So I'm going to get 1 over the square root of 3, all squared. And I know that what I need to do then is just square both numbers. 1 squared is just 1, and the square root of 3 all squared is 3. Okay, and that's where we're at. On a scale of 1 to 10, how comfortable are we with trigonometry, basic trigonometry? Before I add in a Cartesian plane, where are we in terms of basic trig? Okay, I'm liking a lot of the 10s, and if you're at an 8, a 9, or a 10, I'm happy, because that means you just need practice. For those of you sitting at a 5 and a 6, or even a 7, that means fundamentally there may be some things we don't understand, or things that we need to keep looking at over and over and over again to get to a 10. Okay, I love that Nzali's at an 11. You guys are playing around here. People are even above 10. I mean, okay, and remember, all of these marks that we accumulate here, guys, they come from understanding the basics of SOHCAHTOA. Most of it is SOHCAHTOA and Pythag and angle sum and triangle. It's not really that hectic as we go along. Okay, all right, let's have a look at this one over here. Now, this is a Euclidean geometry question. I'm going to give you guys a couple of minutes to look at it. It says here that we've been given a quadrilateral, and it says here, prove that triangle ABC is, what does this thing mean? What does that thing mean? Who remembers? That's it. It said Peter. Oh, it said Peter, you just, lovely, lovely. Somebody said parallel. There are 3 lines, not parallel. Not parallel, Kahelelo. It means congruent. Good. So we're proving congruency, guys. Now remember, we can only use certain rules for congruency. So in your mind, you need to start thinking, yeah, side, side, side. I'm sorry. Then we need to think of angle, angle, side, or side, angle, side, or right angle, hypotenuse, side, or yeah, actually, that's all. Or we can do side, angle, angle, but literally these are the only ways that we can possibly prove congruency. I feel like I've left one out, but I'm going to give you guys some time to cook, okay? And amogelang, we cannot use the fact that they are alternate angles. Have they given us anything to do with parallel lines? No. No, they haven't. Okay, so we can't automatically assume, because it's not actually a parallelogram. They didn't tell us that it's a parallelogram. They just told us that it's a quadrilateral. That's all. And all we know about a quadrilateral is that they have 4 sides. That's all we know. And this shape over here has 4 sides. Princess, I'm watching you. Okay, just cook just enough, ne? Just enough. Just enough. All right, guys. So we always start proofs. We always go proof in triangle, and then we're going to write them out the way that they've given us, A, B, C, and in triangle, C, D, A. And even if they haven't given us the drawing, guys, we can already tell from what we see over here, guys. Number 1, number 2, number 3. I can say AB is equal to which side? Which side is AB equal to? Without even looking at my drawing, what side will AB equal to? DC, good, or CD? Here, I can tell. There. AB is equal to DC. Okay, this is given. They've given it to us. Well, that's what the lines mean. And then I can also say that BC, side BC is equal to which other side? BC is equal to DA or AD. There we go. Okay, BC is equal to AD. That's also given. And then I saw somebody, I think it was Mamela, already give us the last thing. Okay, the last thing we look at is AC and CA. That's basically the same thing. So we can say AC is common. Now we know that this is a side and that is a side, and AC is also a side. So we can say, therefore, triangle ABC is congruent to triangle CDA. And our reason for congruency here is side, side, side. And I'm so glad that you guys are seeing it these days. Like, it's the first thing that comes to mind. You already know where it is. It just pops up at you. It's lovely, guys. It's amazing. Give me a thumbs up if you guys understand what's happening with what we've seen over here. Hi, Princess.
Hello, ma'am.
Hi, my sweetie. What's up?
Ma'am, I wanted to ask, if you say AC is equal to AC and then say common side, was it still the same thing?
Perfectly fine. Perfectly fine.
Thank you, ma'am.
It would make no difference. You would get your marks. Okay.
Yes, ma'am.
All right, my sweetie. Okay, you and I are saying the same thing. If you say AC is equal to CA common side, 100%, or AC is equal to AC, perfect, perfect. Okay, then it says here, what type of quadrilateral is ABCD? Justify your answer. I want anybody to come and tell us, what kind of side are we looking at over here? Anyone? What kind of quadrilateral is ABCD? Nkechi.
Hi, ma'am. So
Listen.
ABCD is a rectangle because there are two pairs of opposite sides that are equal.
That are equal, but a rectangle would have to be very specific. What do we know about a rectangle? What would it have to have? What would the angles have to have?
90 degrees.
Good. Do we have any 90-degree angles?
No.
No, they haven't told us anything about 90-degree angles. So we can't make that assumption, right? But we know that a rectangle is also a parallelogram. So I'm going to go with everybody who says it's a pararara. I love that, a pararara. We're gonna go with a pararara. Love it. Thank you, Anatida. It's stolen. It's mine forever and ever. Thank you. I love it. Yes, like a parallelogram. Love it. Okay, we can say that it's a parallelogram. And the way we're going to do this is we're going to use, who remembers that acronym that we learned? After we've proven that two things are congruent, what is that long thing that we learned? That's the one. It's missing something, right? CPCTC, right? Which just stands for concurrent properties of congruent triangles are congruent. That told me that my angle D will be equal to which angle? Which angle will angle D be equal to, guys? To angle B. Good. And that in itself proves that this is a parallelogram. I've got to run. I'm seeing Teacher Nelly already being like, Teacher Coco, you gotta go. Good. Angle D is equal to angle B. And the reason for that is because we've proven that the triangles are congruent, or CPCTC. I think your teachers prefer you guys writing that triangle ABC is congruent to triangle CDA. Just ask your teachers about that. Make sure that we're not getting it wrong. All right,